Hey everybody, today's lesson is going to be on solving equations. Now this may be a topic that you have covered before, okay, but we're going to be using solving equations a lot here in Algebra 1. So it's something I want to make sure we're all kind of on the same page with before we continue. Now, I'm going to write two things here, and I want you to try and identify some key differences. Okay, well, first thing you should notice is there's a lot more going on in this bottom thing. Okay, this 2 plus 3 equals 5. Okay, well, it has two additional things. It has this 5, right? It also has this equal sign. And since it has an equal sign, this is considered an equation. Okay, and that's what I'm going to be dealing with. Everything I'm going to be dealing with for this lesson is going to be an equation that has an equal sign. Okay, up here, this 2 plus 3, this is just an algebraic expression. Okay, technically what we did, we took this algebraic expression and down here we evaluated it and said 2 plus 3 equals 5. Okay, so that's a big difference, okay? Anytime there's an equation, okay, it means that this left side equals this right side. This is balanced, they're equal, both sides have the same value, however you want to think about that, right? Because this is 5 equals 5, right? Okay, hopefully nothing new there. Now, solving equations, okay, what does that mean? Okay, well, if I have the equation, again, it's an equation because there's an equal sign. What we're trying to find out is what is the x value, okay, right? Because x is just a variable right now, or it is a variable with a undetermined value. We're trying to find out the value that makes the left side, this x plus 3, equal the right-hand side, 5. Okay, so we need to find some value for x to make this true. Okay, our end goal is to get x equals something that we plug back in to make this true. Okay, so how are we going to do that? Okay, well, on the left-hand side, we have x plus 3. Our end goal is to get just x. Okay, so basically we want to get x by itself. How can we do that? Well, we have a plus 3 over here. We're going to do the opposite operation to, I'm doing air quotes and you can't see it, to get rid of it from the left-hand side. Basically, I'm making this 0, right? Positive 3 minus 3 becomes 0. Okay, well, if I do that to the left-hand side, to keep this equation balanced or equal, I need to do the exact same thing to the right-hand side of the equation. Okay, so whatever you do to the left-hand side, you must do to the right-hand side. Okay, and if I really want to, I could rewrite this as this is now x plus 0, right? 3 minus 3 gave me 0 equals 5 minus 3, 2. Okay, well, we know that from our addition identity, okay, anytime we add 0 to a value, we just get that value. So x plus 0 is just x, right? This is just x equals 2. And I know this kind of looks redundant, but I'm just writing down here this big x equals 2. Okay, we found the value for x. That makes this equation true, right? 2 plus 3 equals 5. Okay, I'm going to circle this answer, my solution, because it is true. Okay, let's do another example real quick. Let's do y minus 4 equals 10. Okay, again, it's an equation because there's an equal sign. I'm trying to find the value of y that makes this true, this equation true. Again, my goal is to find y equals something. Okay, well, again, I want y by itself, which essentially means I'm going to try and get rid of this minus 4. I'm not getting rid of it. That's not a very math term way to explain it. Essentially, I'm just trying to get it to be y, plus 0 by itself, y by itself. So to do that, I have a minus 4. If I add 4, okay, this is going to become 0. You might have heard it as canceling out. And I'm probably going to refer to it a lot as we go forward as canceling out, but know that what's actually happening is this is becoming 0. Okay. And again, whatever I do to the left-hand side, I must do to the right-hand side to keep it equal. So I added 4 to both sides. Now, again, technically, and a lot of times you'll see teachers, and myself included going forward, again, kind of saying this cancels out. Again, what's actually happening, this is now y plus 0 on the left-hand side. Okay, on the right-hand side, we have 10 plus 4. It's going to be 14. Okay, and again, this y plus 0 is the same as just y, right? This is the exact same. Y plus 0 is just y. Okay, which means this is just 14 then on the right-hand side. Okay, so y equals 14. If I plug that in for y, I have 14 minus 4. Again, I'm just checking my answer over here. That's what's going on. Equals 10. 14 minus 4 is 10. 10 equals 10. That's true. That is correct. So y equals 14 is my solution. Okay. Let's try another one. Okay, let's do 6 plus x equals 2. Okay, again, it's an equation because of the equal sign. I'm trying to figure out what value of x makes the left-hand side equal the right-hand side. Okay, what value of x is going to make this 2 on the left-hand side? Now, again, we're trying to figure out how x equals. How do we get x by itself? Well, that means we're going to have to make this 6. We're going to do something with it to make it 0, right? Because again, we want just x by itself. Okay, and again, you might have heard it as canceling it out. Well, to make 6 0, we're going to subtract 6, right? 6 minus 6 gives you 0. Okay, same thing as the left or right-hand side. Whatever I do to the left-hand side, I must do the right-hand side. So I'm going to subtract 6. Again, these cancel out or 0 out. It's become 0. I'll write it again. 0 plus x. Looks like a t. 0 plus x equals, okay, what's 2 minus 6? That's going to give us negative 4. Okay, again, 0 plus x is just x, so x equals negative 4. I'm going to plug this in to check. 6 plus, in parentheses, negative 4 equals 2. Okay, 6 plus negative 4 is the same thing as 6 minus 4. Okay, 6 minus 4 is 2. So 2 does indeed equal 2. Again, it checks out. X equals negative 4. Okay, let's do another one. Okay, I'm just doing a lot of examples in this video. All right, let's have 3/4. Okay, we're throwing in some fractions. Don't be intimidated. 3/4 equals x plus 1/4. Okay. This time the variable is on my right-hand side. That's fine. Again, we're still trying to figure out what x equals. Okay, and again, we're going to do the same exact process. This time it's just with fractions. To get x by itself, I want to, again, 0 out this 1/4. I'm going to do that by subtracting 1/4. I'm doing the opposite operation. Okay, if you haven't caught on to that yet, we're adding 1/4. Okay, to solve this equation, I'm going to do the opposite operation and subtract 1/4. Okay, and again, if I do it to one side, I must do it to the other. Okay, I didn't give myself as much space this time. All right, I need to move this a little bit. Let's do that. Move this a little bit more. Okay. All right, so we have this again, the 1/4 minus 1/4 became 0. Okay, so my right-hand side is just x plus 0, or just x. All right, and my left-hand side is now 3/4 minus 1/4. Okay, we already did a lesson on adding and subtracting fractions. Okay, anytime we're adding and subtracting fractions, the first thing we should look for is if they have common denominators. Okay, we looked out this time, they do have common denominators, right? They both have a denominator of 4. Okay, so we should recall that our denominator is going to stay the same, right? It's just going to be 4, right? And our numerator is going to be 3 minus 1, okay, which is just 2. Okay, so we have 2/4 equals x. Now, this is technically correct, but it is not the answer that we want. We can keep going a little bit further, right? We can simplify this, all right? And again, we already did a lesson on this. 2/4, we can divide both a 2 and a 4 by 2 to simplify this down to 1/2. So x equals 1/2. Okay, I'm going to check that real quick. I have okay, so we had this is the equation that was given to us. 3/4 equals x plus 1/4. We said x equals 1/2. Okay, let's check that. We have 3/4 equals 1/2 plus 1/4. Okay, right away we should notice that we're adding fractions on this right hand side and we do not have common denominators. Okay, so that means we're going to have to do something to our denominators to get them to be the same. Okay, on the left hand side I'm not doing anything with that yet. I'm just rewriting 3/4 again. Okay, 1/2. Okay, I'm going to work on it down here in the left hand corner. The 1/2, if I want a denominator of 2, I'm going to have to multiply that 2 in the denominator by 2, right? Because 2 times 2 is going to give me that denominator of 4. Okay, but again, I can't just multiply by 2. I have to multiply by 2/2 because that's just a fancy looking 1. And that's going to give me 2/4, right? Remember, when multiplying fractions, we just multiply across. Okay, so I'm now rewriting 1/2 as 2/4. Okay, and again, I did that because I wanted common denominators. So I now have 3/4 equals 2/4 plus 1/4. Again, I'm just checking to see if this is true. 3/4 equals, okay, 2/4 plus 1/4. They now have common denominators. I can just add the numerators together. 2 plus 1 gives me 3. Keep my denominator, and it checks out. Okay, so x equals 1/2 is correct.